Today we're looking at things you should already be familiar with, which is midpoints of lines and perpendicular lines. However, we're looking at them in the context of circles. We can find the midpoint between these 2 points using this formula. Essentially, we're finding the average of the x and y coordinates. So we're adding them together, so 2 plus 6 for the x coordinates, 3 plus 5 for the y coordinates, and dividing them by 2. So the midpoint is 4, 4. If we wanted to work out the equation of the perpendicular line going through this midpoint, like this, we need to first of all find the gradient of our line given to us. So for every 1 it goes to the right, it goes up a half. Or it goes 4 across and 2 up, so we do 2 over 4, which is 0.5 or a half. To work out the gradient of the perpendicular line, you find the reciprocal of the gradient, so the reciprocal of a half, or 1 over 2, is 2 over 1, so it would be 2, and you flip the sign. So if it's positive now, it will be negative for the perpendicular. So the gradient of our perpendicular line will be minus 2. We can use our equation form here to just plug in the gradient and the coordinates we know, because we know it goes through the midpoint 4, 4, to find the equation of the line. So the equation of the line in y equals mx plus c form is y equals minus 2x plus 12. Let's have a go at these questions. In this question we're told that 2 points A and B are endpoints of the diameter of the circle. And we're told that A is at point 23 and B is at 87. We're asked to find the coordinates of the centre of the circle. We're going to start by drawing a sketch of what's going on. It's always much easier with these questions to sketch it out first so we don't miss anything. So we're told that A is at 2, 3 and B is at 8, 7, so that's roughly here and here. It doesn't matter if it's not exact, just make sure that they're to the right side of each other and that if they're positive they're in this quadrant. If they were negative you would put them in the quadrant that they need to be in. And we're told that they are the endpoints of a diameter, so the circle sort of goes like this, and they're both the start and the end of that diameter. Next, we need to find the centre of the circle, so we're going to label that on. So the centre of the circle will just be the midpoint of line AB. So this is just a fancy way of saying find the midpoint. And we know that the midpoint is found by working out the average of the x's and the average of the y's by adding them together, dividing them by 2. So we're going to do the x's together. 2 plus 8 is 10, divided by 2 is 5, and the y's, 3 plus 7 divided by 2 will be 5. So the centre of the circle will be at 0.55. In this question we're told that the centre of the circle C is at minus 2, 10, and a point in the circle A is at 4, 7. And we're asked to find the coordinates of point B, which lies directly opposite A on the diameter of the circle. So again, let's sketch this out. This time we've got negative coordinates, so we need to have the 2 quadrants in. And we know that A is at 4, 7 and B is somewhere over at the top left because C is in the middle here. So C is at minus 2, 10. So B must be at this top left bit. Now, we know that to find the midpoint, we use this formula. However, we're given the midpoint of the line, which is the centre of the circle. We just need to find out what B is. So we're going to label B as X and Y. And we're going to try and solve this equation. So we need to look at the x coordinates first. So we're just going to look at the x coordinates. 4 plus x over 2 equals minus 2. Draw our lines in and times both sides by 2. So 4 plus x equals minus 4. And then we're going to take away 4 both sides, so x equals minus 8. Next we're going to look at the y coordinates. And we can see that 7 plus y over 2 is 10. And times both sides by 2, 7 plus y is 20, and then we're going to take away that 7, so y is 13. So the coordinates of our point B will be minus 8, 13. In this question we're told that points A and B lie on the diameter of a circle, and point A is at 1, 4 and point B is at 7, 16. And we're asked to find the equation of the line that passes through the centre of the circle and is perpendicular to the diameter AB. There's a lot to go through with this question, and it's really important we draw a diagram first. So we know that A is at 1, 4 and B is at 7, 16, so it looks something like that. We know that they lie on a diameter, and so we can draw the circle in. What else do we know? Well, we don't know the centre yet, but we do know that we're trying to find the perpendicular to that. But we're going to focus on the centre first. So the centre would be the midpoint of line AB, so it will be 4, 10. Next, we need to find the gradient of AB. So we're going to do change in y over change in x, or 16 take away 4 over 7 take away 1, which will be 2. So the gradient of line AB is 2. Now, we're looking for the perpendicular, so we're going to label this onto our graph now. Perpendicular will be at 90 degrees, so it's this one here. If our gradient of our line is 2, then the equation of the perpendicular, the gradient of the perpendicular will be the reciprocal of that, which will be a half, and because it's positive, it will switch sign to negative, so it will be minus a half. We can use our equation form, y minus y1 equals m brackets x minus x1, and just substitute in the values we know. So we know the gradient, and we know that it goes through the centre, which is 4, 10. So substituting the values of y equals 10, x equals 4, and m equals minus a half. Expand the brackets and add 10 to both sides. So we know the equation of that perpendicular line will be y equals minus a half x plus 12. And let's finish with this. A is at 2, 3, B is at 5, 6, and they're endpoints in the diameter of a circle. We need to explain how you know that the centre of the circle is not minus 3, 7 without working out the answer. If you think you know, let me know in the comments below. And you can come to onmaths.com or click the link in the description to access all of our free A-level papers and predictions, and you can even save your scores with a free account. This video is part of a larger A-level course that you can follow along with at onmaths.com.